Okay guys, today is an unexpected video. I just went to use this little vacuum cleaner and it no longer powers up. Plug this in just to show you. Right here. Absolutely nothing. Now if this wasn't a decent small vacuum, I would not even bother fixing it, but I'm going to take it apart and hopefully figure out what the problem is. We're going to test the cord, we're going to test the switch, we're going to take a look at the motor, and possibly there's a thermal cutoff inside there that might have failed, preventing the unit from turning on. To start, I'm going to pop off the end, remove the handle, push down right here, pull that off, spin this down, pop the wire off, lift that up. Okay. The next step is to unscrew the Phillips screws all the way around the housing so I can separate the two halves. Okay, all the screws have been removed. This one's just sitting in there, and the same for this one. Now I got to remove the screws inside the end. Right over here, there's two of them. Once that's done, I'm going to take a utility knife blade and cut right down that seam over the label. There it goes. Okay, we lay it this way. Perfect. Let's take this off. Push it to the side. Everything is opened up. You can see the motor, the power switch, and the plug. I'm going to take you through each step because this is going to apply to pretty much all the vacuums that are sold. You have a power cord, you have a switch, you have a motor, and more than likely in here, we'll take a closer look, is going to be a thermal cutoff. There's brushes on this motor. So the first thing you want to check is to make sure there's continuity between each blade of the plug and the end of the wire that goes into the vacuum cleaner. In order to do that, you're going to need a digital multimeter, and you're going to put it on a continuity alarm setting. Right here you can see the indication. When the probes are touched together, you're going to hear an alarm, and that alarm is going to indicate a connection between the blade and the end of the wire. If you test between the blade and the end of the wire, and the alarm does not sound, that's an indication that there's a break in the wire between the plug and the end. So let's test that first. So right here we could see the black wire goes to the switch, and it's the one that's got the cover on it. Right here you can see I have an alligator clip connected to the red probe. Lay it right there. Now the black wire is the one we're looking at. So the black wire is always going to be the smaller blade. That's narrower and that's wider. I'm going to connect it right on here. Now I'm going to take the other end of the probe and push it right where it connects to the switch. Alright. And we have continuity, so this side of the plug is good. Now we're going to switch to the neutral side. And if you look right down in here where the power cord enters, you're going to see a white wire. So let me lift that up so I can insert the probe into the pigtail. You can see it right there. Now I'm going to push this all the way in. You've now effectively ruled out the power cord as being a problem. The next step is to check the switch. To test the switch, you're going to leave it on the continuity alarm setting. If you do not have a continuity alarm, then what you want to do is put it on the lowest resistance range for ohms. You can see right there is the symbol for ohms. When you connect it together, you're not going to hear the alarm, but you will see 0.0 or 0.01 or 2. It's going to be a very low reading if the circuit is a full loop. So what you want to do is take this right here, connect it to one side of the switch, and this probe to the opposite side. In one of the positions, on or off, you should hear the alarm sound. If you don't, you're going to know it's a faulty switch. So let's try this first. Nothing there. How ridiculous. And this was an easy fix. This switch is cooked. Yeah, the switch is bad. Alright, so the problem with this one, very simple, the switch is faulty. So let me slide the blade connectors off. Let's take a look at the switch. But when I'm done swapping out the switch or fixing it, let's take a look at the motor as well. So just in case your switch is good, you know what to do next. In order to remove the switch, you need to pull off the blade connector, but the blade connector has a protrusion that goes into the male blade on the switch. So I'm going to show you what you need to do. You can use the probe on your digital multimeter, and there's going to be a little tab sticking up on the inside. Right there, it's spring-loaded. I hope you can see that. If I can push it this way, you'll see it stick out that side. Hopefully you can see that. You're going to push that through at the same time while pulling on the end. So let me try that in front of the camera, and there you go. So it's very simple. That's one. Slide this up. You can see that tab that sticks up. You need to push it this way towards the camera. So let me, and right there actually is pretty good. Right there you can see it. Push it in, pull it off. Okay, now a closer look at this switch. Single pole, single throw. And there's a hole right there. That's a pin that locks in for the pivot point. So in order to pop this out, what you want to do is take a flat blade, a thin one, and you want to insert it right over here and pry. So let's see if I could do this with the camera right in front of me. Okay, got it. And let's take a look in here now, really up close. And right here you can see a metal plate along with a spring and a pin. The spring right over there goes inside the hole on the back of the button, and it pushes down on that pin, which changes the positioning of that metal strip, which rocks back and forth. So when the metal strip is pushed in one direction, it's going to make a connection between these two pins, and if you push it this way towards me, like that, it's going to open the connection between these two. So clearly there must be a lot of carbon in here. Let me dump this out and take another look up close. With the metal plate removed, along with the spring and the pin, you can see the round brass or copper colored contact has an area of thick carbon on it. So what I need to do is very carefully clean away the carbon on that little area right there. You can use a pencil eraser. If it's really thick, you could try scraping it very gently with a piece of metal and then use a pencil eraser. Once that's done, we also need to clean the metal strip that's going to be rocking back and forth between these two posts. Now this, I'm just going to very gently take the back of this X-Acto knife, just drag it over the surface, make sure there's no crud. The contact has a special plating to make it resistant to the arcing that occurs when the contacts are closed. So now I want to take this pencil eraser and just keep erasing it to clean it up. This is what I used to do many years ago when I was a kid. I had a Tyco racetrack, and every time the cars went over the track, the bottom rails that rubbed against the track would get burned up, and in order to clean them, you just take a pencil eraser and it would be like brand new. And look at that. That contact is perfect. Now let's clean the other one. A little more difficult to do. Take the end of this tip and just very gently scrape away that crud on there. Electrical contact cleaner is not going to do too much, unfortunately. You got to get in there with this eraser. So let me do that. In this case, just put it in there and just keep spinning it around, because you can't go left and right with it. And we'll see if it's cleaning it. Yep, look at that. That is beautiful. And you can use an eraser on all types of electrical contacts. If you see any carbon on them, it works extremely well. Let's see, this should be great. Oh yeah, that's done. Tap out. See right there. This point right over here needs to face down over there. And you see this notch? The notch in the metal plate has to line up with these two tips sticking up over here on this terminal. So let me put this in position so you can take a closer look. Right there, it's now in position. This is the part that pushes down on that. Really no need to clean this because electricity is not flowing through it. And insert it into that hole. And then you're going to very carefully line it back up and push it back in until it pops. The line is on. So if I push it to on, right there is on. That's the way it's got to go. So let me just hold this at an angle. Right over here, that should be off. So one there. Good. And now it should be on. Hey, and the switch has been fixed. Okay, before I put everything back together, let's take a closer look at the motor. Right over here, you can see the commutator. That's all those copper strips with spaces between them. And this is a brush holder. There's a brush holder in the back. I'll pop it out in a minute to show you. And you can see right in there where the brush makes contact. Let me pop this out of the unit. The motor is out of the housing. Now right here is just a mounting bushing. You can pull that off. And this is well made, this motor. Not surprising for a Bissell. This whole end could be unscrewed from this metal section of the motor with the windings on it. And inside this plastic end, well, you have your bearing right here. If it gets very noisy, you would have to unscrew these two screws, pull off this plastic cap, then push out the bearing and install a new bearing on the end. If the brushes go, you could do two things. You could push down on this little tab inside right over here. You could see it up close. And when you push down on that, after this is desoldered, then you could just pull this whole brass tube out of the end of the plastic and the brush will be inside. You can install a new brush holder, push it until it clicks, solder it back, or you can even pry open the end like I would do and go to like an Ace Hardware or a True Value or any other hardware store where they have a little kit of brushes that you can choose from. Find one that fits inside, reassemble it, solder it together, and then you should be good to go. Now the way to tell if you're not making good connection with the brushes is very simple. You're going to have your digital multimeter set to a resistance range. You do not want it on the continuity alarm setting. You want to measure resistance, and that's pretty good. It's auto ranging. Take your digital multimeter, connect up some alligator clips to each end of the probe, and then you want to connect to where the wire is. So in this case, this black wire goes directly to the winding with this brush holder. So I'm going to put one over here. And then I'm going to take the other wire, and because it's connected up right here to the neutral, I'm just going to connect it to the brush holder. So you can see 10.7 ohms. That's good. You have a connection between the brushes and the armature. So what you want to do next is slowly rotate the motor and make sure that there's always resistance around the same range. Because if you find an area where it's no resistance, if it just goes to infinity, that's going to indicate an open winding, and that is not a good thing. So I'm just going to hold the motor like this, put my finger inside, and slowly rotate it. So the brushes are changing where they make contact with the commutator, and you can see there's no problem anywhere on that commutator where there's a dead spot. So we know that's good. Now some of these will have a thermal cutoff or a thermal switch. And if you get absolutely nothing showing up on the meter, there's a very good chance if you do see a thermal switch that the thermal switch has failed and you're going to have to remove it. It's usually right up against the winding of the motor. I'll point out the location because I do not see one on this motor. And you can see at this end, both sides where the connections are made, and I do not see any thermal cutoff. It's possible there's a thermal fuse in there. I just don't see one. But usually they're going to look like what you see right over here, and they're very easy to test using the continuity alarm on your meter. You're going to take the probe, connect it to each one of those legs, and you should have continuity. If you do not have continuity, that's going to indicate the thermal switch or thermal cutoff is faulty, and you're going to want to replace that thermal switch or thermal cutoff using the same rating that's on it. And you could put it right back on using nylon ties in the exact same position that you found it. More than likely you're going to have to solder it in position. So right here, if I wanted to get into here, take a utility knife blade, just cut open this white sleeve, you'll be able to access that soldered connection if this area was where the thermal switch was mounted. And guys, there's really not much else with this motor. You want to look at the windings, make sure that they're not burned. You should see that brass color or copper color. It should not be black. If it's black, that means you overheated the motor, and that's not a good thing. But this one here looks pretty darn good. So let me put this back together and let's see if it works. Let's put this back on. That's locked. And we're going to take this one here and put that one on as well. Okay, let's push this forward is on. That's off. Alright, now that we're back together, let's plug it in and give it a try. And that's it, guys. I hope you enjoyed this video. If you did, be sure to rate thumbs up, share, and check out my extensive video playlist for many other videos of interest to you. Thank you very much for watching.